So today I'm going to start looking at the NGL OBJ class, which allows us to load in an OBJ. And for some of these demos, what I'm going to do is I'm going to use a very simple cube. So what I've done for this is go to create polygon primitives cube, and I've created a simple cube. Now the first thing is any meshes in NGL need to be triangles because the OpenGL doesn't handle quads like this, so if you select the mesh, go mesh and just triangulate, and then you get your nice triangular mesh instead. And that's important because NGL OBJ will just reject anything of higher order. It will attempt to convert quads into triangles, but it's easier just to make sure they're triangles to start with. And what we're going to do is, if you haven't done so already, you need to go to Settings, Preferences, Plugin Manager, and if you just go into the search and do OBJ, you'll notice there's an OBJ export.mll. I've got it auto-loaded. Normally it's there by default anyway, but just in case you can't find that. And then you go File, and in this case I'm just going to Export Selection, and then you can choose at the bottom there, which is off screen, I just noticed, you can choose OBJ export there, and you can see here you've got lots of options. I'm turning off groups, point groups, materials and smoothing. It's just not needed, and in fact not handled by the NGL OBJ loader anyway. And I'm just dumping this out as cube.obj. And if we have a look in the folder here, cube.obj has been exported. The OBJ file format is nice and easy. We have a list of vertices beginning with V. So there you can see my unit cube's individual vertices, and you'll notice that as it's a unit cube, they've all got their dimensions centered at the origin and half extents going through. Then we've got VT. These are the texture coordinates. These are nicely mapped to if we go to the UV editor here and look at, where are we, UV editor. If you look at how the cube is unwrapped in Maya by default, then it does it and unwraps it like this. If you look at most of the demos where I create my own cube, I just map each face to be exactly the same. So that's something to be wary of, but it is useful if you want to do individual triangles and have different ones there. So that's something to be wary of exporting from Maya, that the UVs that are exported are these ones here. And again, if we have a look, you can see how that's all gone through. And then we've got our normals, and it's a per vertex normal, as you see here. So we've got lots of repetition in this data. That's just, again, the way that it's been exported from Maya in this case. Sometimes some of this data will be shared depending on your mesh exporter and so on. If you do want to do lots of mesh transformation, there are some really good tools out there for doing that, and there's some of it installed on No Machine. I may talk about that later, but for now we're not overly worried about processing them with other tools. There's a tool called Meshworks, which is particularly good for doing that. And then finally we've got our faces. So the faces are indices into the other lists. So we have vertex, UV and normal, I believe. I always have to look it up because I can never remember. So that's the index into the list. And notice that this list begins, annoyingly, at 1. Whereas if we were to store these in standard C arrays, that would be indexed at 0. Therefore, we have to subtract 1 when we load in these files and do processing. Again, NGL OBJ does all of that for you, so it makes life easier. So we will have a look at that in a little while in the next video about how we load in an OBJ and what we can do with it. So I'm going to start by loading in an OBJ. So if I do a hash include ngl/obj.h like this. Now there are two choices with the NGL OBJ, you can either create an empty OBJ object and then invoke the load method to load in a mesh, or you can construct it and it will load in the mesh itself as well. So we will look at both of these processes because it can be quite useful to do it either way. There is also another caveat which we'll look at a bit later, but it is possible to convert this mesh into a vertex array object used with OpenGL. But to do that, we must have a valid OpenGL context, and we can also load in a texture at the same time, which is a nice convenience, and associate the two as well. But again, we must have a valid OpenGL context to do this. So in this case, we're going to do a simple console-based program. I'm going to say NGL OBJ, and I'm going to call it cube because we're loading in a cube, and we're just going to say cube.obj like that. And if I go through and just compile this now, so I'm just going to run my build and run it. Now, this is a path and a file name combined together. So at the moment I've got cube.obj here. So that means that this file must be in the same location that the executable is running from, or a relative path from that. Typically what we'll do if we're creating an NGL demo, we'll have a folder called meshes and have everything relative to that where it is. But that mesh management is something that must be done to do it. So at the moment you can see nothing's happened there. Now the mesh is actually in this folder because I've modified my CMake lists to copy cube.obj to the target executable folder. So we know that's working. Now there are a number of different methods to the OBJ class. There's a default constructor. There's a constructor which will also take in a texture name and a file name. There's a copy constructor. There are methods to set textures. There's methods to actually build up an OBJ from our own data, and then we can write it out. So if you're writing your own modeling tool or something to do deformations and things like that, it's very easy to add your vertices, your normals and your UVs, and then build up faces from those and write it to a file. We'll look at doing something a bit like that later. We've got a load method, a save method, and there is the isLoaded method, which when we load successfully a file, that will be created. So if we just go back now and say if cube.isLoaded, and then we can sort of say stood cout cube load okay, line, so we can check our code to make sure that's worked. So if we try that now, we should see that it has successfully loaded the mesh. Let's do that, and you can see cube loaded OK. If I were to say cube1.obj and just try and do that, that file doesn't exist. So let me try that again, and you see it's not loaded OK. So that's how we check these things. That's the first part of that mesh. So what I'm going to do next is have a look at how I can access information about the mesh. So the next video we'll take a dive into that. So NGL OBJ actually inherits from the NGL abstract mesh here. And if we have a look through abstract mesh, you'll see that this is basically how meshes are represented internally in the NGL library. And in particular, it's designed to hook into the VAO factories and everything else. And there's a whole series of different methods in here that you can delve into. So we can draw bounding boxes. If we've calculated one, we can draw the mesh itself. We can access the underlying VAOs to do things. We can get the buffers IDs for that. We can load textures to them. But for the OBJ class itself, the sort of more interesting stuff is the ability to access the underlying mesh data. So we can get lists of the vertex, we can get the vertex at a particular index, we can get the normals, we can get the UVs, we can get the face. List is a bit of a misnomer because they are actually stood vectors, as you can see, but it's all the information there. We can also get the overall dimensions. So if we go back to our basic demo, which is that one there, once we've got our cubers loaded, what we can do is we can say stood cout cube dot get num, and we can say how many faces are there in our mesh, for example. And if we run that, we can build and run, and we'll see that it should tell us how many faces there are. And don't forget it's triangulated, so it's not going to be the standard 6 faces. It should be, so you can see there, 12 faces, because each face has 2 triangles there. So that's quite useful that we can get all of that information, so we can write information out about it. So num faces like that, and we can also get information like num verts, number of verts. We can get num normals and num UVs. And that can be useful for looping and things like that. So number of normals and number of number of text chords, I call it, rather than UVs. So if we build that, we can run through and have a look and see that. Now that can be quite useful, but also we can actually get the underlying data. So we've got 12 faces, 8 vers, 24 normals and 14 UVs. That's some useful information there. What I tend to do is if I say auto faces equals cube dot get face list, and what that's going to do is that's going to return a structure which is here we go, it's a stood vector of this face structure here. So if we look up here, the face structure is a very simple class structure. So it has internally a data structure which has got a number of vertices, number of normals, tells you how many vertices are in it, whether it's got texture coordinates or not, whether it's got normals or not. And if we dive in, what this is an index. So it's an array of indices for each of the elements of data that we've got in here. So what I'm going to do is, if we have a look back here, I've got my faces here. If I say auto face equals faces subscript 0, that's going to return a face structure. And then I can say stood cout face dot, and now you can see that we've got norm, normals, number of verts, and what we should see is that that is going to give us the value 3, because I've already triangulated this mesh, and basically this is going to be the index into the other lists for our mesh. If I run through there now, oh, it's given me 0 for some reason. Get face list. I don't know what's gone wrong there. that should have given me, let's just get mnumverts. Put size there. We should see how big that is. Something may have gone wrong in my mesh loading. And I am loading the correct mesh there, I believe. Yes, so 3. So for some reason that's not been set. I'll have to check that. So what we can now do is loop through each one of these and index into our other data lists to begin to process the OBJ data. And I will do that in the next video. So I'm going to grab the rest of the data from the OBJ here. So auto verts equals cube dot get vertex list. So it's going to give me a std vector of ngl3s, and I'm going to do similar auto normals equals cube dot get normal list normals, and then go auto uv equals cube dot get text text get uv list. There we go. So face, vertex, normal, uv there, and then obviously I've got my faces here, which is giving me the information of the faces. So what I'm going to do is I'm now going to say for int I equals 0, I is less than 3, increment I, and what I'm going to do is I'm going to get the vertex information for the first face that we have here and print out all of that information. So basically what we need to do is to say std cout verts, and what we're going to do is say face dot m underscore vert at index I. So if I just do that to start with, and what that should do, here's our list of vertices, and here's our list of faces, and what we're saying here is from face subscript 0, so the first face, give me the index for the first vertex in that list from the face and from this list of vertices. Now there's a good chance that value is going to be 0 when we print it, and what we'll get is just the first vertex in our OBJ list. And there you go. So minus 0.5, minus 0.5, 0.5, 0.5, minus 0.5, 0.5, all the way through there. So what I'm going to do next is print out the, so let's just, so that's the vertex. So next we'll have the normal, so let's just put a space in there, and then we're going to say normals subscript face dot m norm subscript I, subscript I, close that for me there, and we might as well just do the UVs while we're here. Let's get it all right. So normals for the current face, subscript vertex in there, and we'll do the same for UV for the current face, m underscore UV square bracket index I, and then finally we'll print that out. So what hopefully we should see now, as long as I haven't made too many mistakes in the printout, is the information. So there we've got the vertex, there we've got the normal, there we've got the texture coordinates. And notice the texture coordinates coming off as a vec3 as well, because some models also do that. So at the moment I'm using face as just the first one, but obviously what I can now do is also go, so for auto face in faces, and then I can loop through for each of those faces and print out that information, and that should basically give me the completely reconstructed data for that cube that I've got, which should then match up for everything else. And there you can see there are all the individual triangles with the UV as the normals and the UVs as we go through, and you can see they're all gradually changing as we go through and so on. So it's very easy to take a mesh from an OBJ and then access the internal data. And what's great is if we've got this internal data, we can then apply transformations and deformations and various other things, and then load that directly into a vertex array object as a series of triangles if we want to do any sort of mesh processing and things like that. We can also save data out as well, which we'll look at in the next example. So in this demo, I'm going to do something slightly different, where I'm going to create my own OBJ and then write it to the file. So I'm just going to create an NGL OBJ called mesh, and that's just generated an empty mesh. And then what we can do is we can basically go through and make calls to some of the methods. So what I'm going to do here is I'm going to say mesh.add vertex. Let's take an NGL vec3 as the parameters. Alternatively, you can just use brace initialize syntax. So I'm going to add a vertex, and then I'm going to go through and add another couple to form a very simple triangle. So if I add another vertex at somewhere, say 4 like that, and I'm also going to add another vertex at -2 like that. And let's just quickly make sure that builds. So I'll just do a cmake ---- build. Make sure it's happy with that. And then what I'm going to then do is add some UVs. So mesh dot add UV, and this takes an NGL vec3 as the UV as well, but we can also pass it in as an NGL vec2 as well, or just use an initializer list syntax again. So again, I'm going to add 3 UVs, 1, 2, 3, and I'll make this one something like 0.5 and 1, and I'll make this one 0.04, 0.9, something like that. So added some UVs, and finally what we can say is mesh.add normal, and in this case I'm going to make Z upwards, so I'm just going to say 0.0, 0.0, 1.0 like that, and these are going to be per vertex, so I'll just replicate that a couple of times. Alternatively, actually, I could just have one normal and index into it 3 times. So actually I could do it this way. In fact, we'll do it this way. So we'll just add one normal and we'll create a face. So if we do NGL face F, what that does is it gives us the face structure. And then what we've got to do is add the vertices back, then we're going to add the UVs back, and then we're going to add the normals back. So f.mvert.push back, and that's going to be index 0. So that's basically going to point into the first vertex. And then I'm going to do, typically you would do this more procedurally when you're generating it, because you'd have a list of all the vertices and you'd determine how you're doing it. But there are various ways, but it's just bearing in mind how the different formats work. So then it's going to be the UVs that get pushed back. And again, the index in this case, we're sharing, we're not sharing anything but the normal. So in this case, again, it's going to be 0, 1, 2, because we've got the lists that correspond to each one of these. So we've got that vertex shares that UV, and it's going to share this normal. The next vertex is going to share this UV, but that normal, and so on as we go through. So now all we need to do is say f dot m normals, m norm dot pushback, and each one of these is going to have an index 0 because each one of them is sharing the same normals. So there we go. Now we can say mesh dot add face, and we'll add face f, so that's just going to add that face to my mesh. And then finally I can say mesh dot save and test dot obj, and that should hopefully save out that obj when we do it. So let's have a quick look. Let's build. Hopefully I haven't got any errors there. So this is very useful if you're doing some sort of simulation or you're doing some sort of mesh stuff, that you can store your data in this sort of way, and then you can save it out each frame as an OBJ. So there you can see there's my vertex, there's my texture coordinates, there's my normal, and there's my face offsets there. I should be able to now go into Maya. Let's just do a file, new scene, don't save. I should be able to go file, import. You can have the dialog box, but you can go import, and then so I'm in the folder tmp, ngl demos, build, debug, and in here's test.obj there. So I should be able to import that, and there's my triangle that I've just generated. Then you can see the normals are all facing in the correct way, and if we go to the UV editor, you can see that we've got some UVs in there that don't quite match up correctly. Are they matching up at all? Select that. There we go, and there you can see the UVs are sort of matching up correctly as well. So it's really easy to use the NGL OBJ class to generate meshes as well. There are some more in-depth examples of this in the unit tests of the NGL OBJ class. So if you really want to have a sort of much closer look at everything, if you go into the NGL unit tests directory, I thought I had it open but I don't, and have a look in there, you'll notice that there are a whole series of tests that build up various things using that, so you can test it all out, which can be quite useful. So this demo is using the NGL OBJ class to now finally do some visualizations. One thing you can notice is that part of generating the mesh, there are a method called calculate bounding box, which is visualized there as you can see, and we can just draw that quite simply as a simple wireframe line shader, and we can also calculate the bounding sphere. These can be useful for collision detection type algorithms and routines and things like that, so they can be quite useful if you need to do something along those lines. So this demo, as I said, it's important to have an OpenGL context before we generate a mesh as a vertex array object. So typically, if we're writing programs to use the NGL OBJ, we will actually be using the let me just get this one there. So we'll be using the default construction of the OBJ as a mesh. So let's just go through and find where we are. So what we've got here is a stood unique pointer of MGL OBJ called mesh. So this doesn't get constructed now until we've got a valid OpenGL context, and that's the important thing. So what we go through here at the moment is we initialize as we would do normally, set up our cameras, load our shaders, everything else, and then you can see that I'm making a call to mesh.reset, constructing a new OBJ class, passing in file name and texture name, and these are parameters that are passed on the command line because it allows me to, if I wish, load in default textures and things like that, and actually load in different meshes. Once we've done that, we need to make a call to create VAO, and what that does is it creates the vertex array object for that mesh. Typically what we would do is we would load all of our meshes once and then refer to them by name. What we don't want to do, say that you're creating a game and you've got a lot of rocks and they all use the same rock object, or a lot of missiles and they all use the same mesh, you only ever create that mesh once, because it's expensive to create a mesh and all we can do is instance it when we need to. And I'll look at a demo of doing that in another example. But basically here we create our VAO and I'm calculating my bounding sphere, creating a sphere using that radius and so on. And when we go to draw, it's as simple as making a call to mesh draw, and that will draw that currently activated VAO using the currently active shader. The only other thing to sort of understand, I suppose, with this is when we're generating this, the data comes in as with all NGL meshes, that location 0 is the input vertex, location 1, which is not used in this, is the normals, and location 2 is a vector with the UVs. So it's exactly the same as all of the primitives within NGL. And that's all there is to that basic demo there. There are other demos that use the mesh, so you can see all sorts of different ways of using the mesh and processing the mesh. I've got demos where I take in the mesh and then do things with the UVs and the normals and so on and pass them in. So you can look through all of my demos and see which ones use the OBJ. But that's the simplest level. If you just want to draw a static mesh, it works very well and it's ideal for simple game objects and things like that. But as I say, you only ever load one when you need to do this.